Something is killing galaxies, and scientists are on the case to find out what the reason is. Toby Brown on space.com, today's article. It was originally published on The Conversation, contributed to Expert Voices, Op-Ed's Insights, the most extreme regions of the universe. Galaxies are being killed. Their star formation is being shut down, and astronomers want to know why. What is this? This is something really absurd and astonishing. The first ever Canadian-led large project on one of the world's leading telescopes is hoping to do just that. The new program is called Virgo Environment Traced in Carbon Monoxide Survey, Vertigo for short. It's investigating in brilliant detail how galaxies are killed by their environment. As Vertigo's principal investigator, I lead a team of 30 experts that are using the Atacama Large Millimeter Array, ALMA for short, to map the molecular hydrogen gas, the fuel from which new stars are made, at high resolution across 51 galaxies in our nearest galaxy cluster called the Virgo cluster. This is the image that we're seeing here. This is a Virgo galaxy, constellation of Virgo. Commissioned in 2013 at the cost of $1.4 billion US, ALMA is an array of connected radio dishes at an altitude of 5,000 meters in the Atacama Desert of northern Chile. It's an international partnership between Europe, the United States, Canada, Japan, South Korea, Taiwan, and Chile. The largest ground-based astronomical project is in existence. ALMA is the most advanced millimeter wavelength telescope ever built and ideal for studying the clouds of dense cold gas from which new stars form, which cannot be seen using visible light. Large ALMA research programs such as Vertigo are designed to address strategic scientific issues that will lead to a major advance or breakthrough in the field. Where galaxies live in the universe and how they interact with their surroundings, the intergalactic medium that surrounds them, and each other are major influences on their ability to form stars. But precisely how this so-called environment dictates the life and death of galaxies remains a mystery. Galaxy clusters are the most massive and most extreme environments in the universe, containing many hundreds or even thousands of galaxies. Where you have mass, you also have gravity, and the huge gravitational forces present in clusters accelerates galaxies to great speeds, often thousands of kilometers per second, and superheats the plasma in between galaxies to temperature so high that it glows with X-ray light. In the dense, indisputable interiors of these clusters, galaxies interact strongly with their surroundings and with each other. It is these interactions that can kill off or quench their star formation. Understanding which quenching mechanisms shut off star formation and how they do it is main to the focus of the Vertigo collaboration's research. The life cycle of galaxies. As galaxies fall through clusters, the intergalactic plasma can rapidly remove their gas in a violent process called ram pressure stripping. When you remove the fuel for star formation, you effectively kill the galaxy, turning it into a dead object in which no new stars are formed. In addition, the high temperature of clusters can stop hot gas cooling and condensing into galaxies. In this case, the gas in the galaxy is not actively removed by the environment, but is consumed as it forms the stars. This process leads to a slow, inexorable shutdown in star formation, known somewhat morbidly as starvation or strangulation. While these processes vary considerably, each leaves a unique identifiable imprint on the galaxy's star-forming gas. Piecing these imprints together to form a picture of how clusters drive changes in galaxies is a major focus of the Vertigo collaboration. Building on decades of work to provide insight into how environment drives galaxy evolution, we aim to add a critical new piece of the puzzle. An ideal case study. The Vertigo cluster is an ideal location for such a detailed study of environment. It's our nearest massive galaxy cluster and is in the process of forming, which means that we can get a snapshot of galaxies in different stages of their life cycles. This allows us to build up a detailed picture of how star formation is shut off in cluster galaxies. Galaxies in the Virgo cluster have been observed at almost every wavelength in the electromagnetic spectrum, for example, radio, optical, and ultraviolet light. But observations of star-forming gas made at a millimeter wavelengths with the required sensitivity and resolution do not exist yet. As one of the largest galaxy surveys on ALMA to date, Vertigo will provide high-resolution maps of molecular hydrogen gas, the raw fuel for star formation for 51 galaxies. With ALMA data for this large sample of galaxies, it will be possible to reveal exactly which quenching mechanisms, ram pressure stripping or starvation, are killing galaxies in extreme environments and how they're doing so. By mapping the star-forming gas in galaxies that are the smoking gun examples of environment-driven quenching, Vertigo will advance our current understanding of how galaxies evolve in the densest regions of the universe. Toby Brown, postdoctorate fellow in astrophysics at McMaster University. This article is republished from The Conversation under Creative Commons license. If you'd like to join me on my Patreon account, you will hear content not covered by mainstream media. These riveting stories will be based on my research, and I will state my opinions and give my personal insight on diverse and controversial subjects and world events not covered by mainstream media, and not supported by YouTube guidelines. So whatever I have on my Patreon, most of those will not be on my YouTube channel. Please consider becoming a member today. More of the most significant and important videos will be on my Patreon channel. Your support helps me to continue my research and keeps this YouTube channel alive. And we depend on your support, your generous charity, because we help economically challenged families here in Athens, Greece, in Kapota, and we also help the young generation with university tuition and the community around our church. Thank you.